We have a wonderful speaker from Africa, Mr. Ugonna Okoli, and he will be helping us. Welcome, Ugonna. Helping us understand the networking autonomy and the culmination of natural computing. He is an experienced lab coordinator, managing partner of the User Experience Lab. He's also a full stack engineer with Innovantics Limited and a full stack software developer for hotels in Nigeria. And he will be helping us understand and get a little deeper into how blockchain autonomy and the networking technology of Polkadot for the Web3 can be considered the last important pieces needed to achieve absolute natural computational systems. So, welcome, Ugonna. Welcome to our World Polkadot Forum, and we're so happy to have you here. And looking forward to your participation in this and your talk. So the stage is yours.
Yeah, thank you very much. Thanks for the introduction. So without further ado, I think I should share my slide.
You're welcome to add to your profile if you would like.
Yeah. Yeah. So once again, my name is Ugonna Okoli. I am the founder of CEO of User Experience Lab and founder of Voltage Networks, a blockchain network. And as you have already said, I am a full stack engineer. I have experience working in a number of companies, and I have a keen interest in blockchain technology. So over the years, I've been following the trends, I've been following the technology, and finally building something for the ecosystem. So based on that, I think I would like to share my talk based on my experience and all of that. All right.
Wonderful. We can see you, hear you, and see your presentation well.
Awesome. All right, so I'll be talking on the networking autonomy and culmination of natural computing. So to what end? This is to show how blockchain autonomy and the networking technology of Polkadot for the new Web3 can be considered the last important pieces needed to achieve absolute natural computational systems. So when we talk about natural computing, in simple terms, natural computing is like human designed computational processes observed and inspired by nature. So nature inspires us to do what we do with technology, in science, and in arts also. So in other words, nature has its different algorithms embedded in everything natural with the following characteristics. So talking about nature, nature has a number of characteristics that makes it quite unique, that makes it an entity that we can model systems out of. So one of the characteristics of nature that is important for natural computing is originality. So in nature provides the first principles, the fundamental building blocks for complex ideas. In other words, nature provides us raw materials. When we talk of production, when we talk of even in science and technology, first principles can be traced back to nature and all of that. So the first principle is a basic proposition or assumption that cannot be deduced from any other proposition or assumption. The second characteristic of nature is self-sustaining. It is an ecosystem of ecosystems. Nature on its own can, sustain itself. is a cycle of life. An ecosystem is a self-supporting unit with the ability to maintain itself. So it produces and consumes and creates. It has this self-sustainability to it. The third characteristics is distinctive. Nature by itself is distinctive. Nature has individuality and also diversity, the ability to be studied and documented. So in nature, we can easily distinguish individuality, and also in nature, we can observe diversities in species in animal, plants, and so many other areas of studies. And also nature is predictable. So talking about predictability, the ability to study nature comes with the power to predict and manage causes and outcomes. So all that nature has, we can study it, and out of the study, out of data, we can predict and manage causes and outcomes that comes from it. And the final point to the characteristics of nature is traceability. Nature has an underlying system of trustless identification of its elements. So what this simply is it has nature. By nature, we can easily trace it. Nature gives us a pathway of like footprints to trace the originality of its elements. Looking at our first point, originality. So when we talk of DNA, there's so many uses of DNA. We can use it in genetic genealogy, ancestry, tracing, species, relationship between species and all of that, carbon dating and all of that. So all these are found in nature. Now focusing on traceability as one of the characteristics of nature, by which when we are modeling computations out of nature, before now, computations were just based on other characteristics of nature. We could model a system that does things that are observed in nature, but traceability wasn't there per se. So natural computing hasn't captured an absolute model from its nature counterpart because of traceability. An important point to security, which blockchain technology has solved. So with blockchain technology, we are not talking about trustless systems, the ability to make transactions without depending on third-party verification systems. So the system itself provides that trust for transactions that can be traced and all of that. And this is what nature by itself provides. And moving forward.
This is, Ugonna, this is really, really interesting. So in looking at nature itself and how nature functions and how it's sustainable in various environments and various epochs or time periods, you're looking at how this can inform Web3 and how we move forward in Web3, right?
Yes,
yeah.
That is part of the point.
Yeah.
We can draw our lessons from nature and how it can inform our innovation in the Web3 space. Yeah. So looking at engineering natural computing systems, natural sciences are concerned with the study and formalism of natural phenomena. Mathematical and computer models of these phenomena are designed either for a better understanding of nature or for being applied to problem solving. In order to develop such models, it is necessary to gather knowledge about the structure, dynamics, and the metadynamics present in natural phenomena. And these have to be incorporated in the models. So this just describes how we can take the lessons, the sustainability, the lessons that we can observe from nature. When we study nature, we can model that into systems, especially as you have pointed out in the Web3, lessons to draw from there. If we want more sustainability, if we want to have more natural processes and more of the characteristics that nature itself has, we can copy nature into the Web3 to create more sustainable systems. So examples of natural computing algorithms, we have the nearest neighbors algorithm used in image search engines that was kind of inspired by studying the fly brain. So algorithms, like we have Google image search, engineers and scientists had to study how fly processes images. So out of that study, they were able to build an algorithm that can process, that can behave like a natural phenomena. So in a general sense, natural computation, it's kind of related to artificial intelligence, where we talk of neural networks and all of that. So, and the second example here is object recognition algorithms. It inspired the first convolutional neural networks for computer vision from studying cat brains. So once again, scientists and engineers took inspiration from studying how object recognition is being done. Looking in depth, there's a study on that. You can go further to look at how it was done. So an algorithm was created out of that study that helped, that delivered better processing when it comes to object recognition and so on. And also negative selection algorithm using identifying bad network systems. This is inspired from our immune system. So the human immune system was studied, and out of that study, they were able to model an algorithm that helps identify bad network, bad players in a network. The last example here is the swarm intelligence algorithms that is inspired from insect colonies used in building decentralization of complex structures. So we know swarm colonies like the bees, the ants, and so on, they have like an organized system. They are able to build, their colony independently, but still somehow connected. So there's a science to that, which in computer science, we also have a branch, the swarm intelligence computation, that it's a study of its own, where we can learn certain benefits, and it's being used in decentralization of complex structures, basically. So moving on to the next topic here, subtopic here, blockchain autonomy. So why I have talked about nature, its characteristics, pointed out some examples, and how can we relate this to blockchain ecosystem? The multi-chain vision of Polkadot. So looking particularly at Polkadot, Polkadot unites and secures a growing ecosystem of specialized blockchains called parachains. Apps and services on Polkadot can securely communicate across chains, forming the basis for a truly interoperable, decentralized web. So our focus here is Polkadot is like a blockchain of blockchain. From our characteristics of nature, we know that sustainability nature by itself is self-sustaining because it's like an ecosystem of ecosystems. And Polkadot has kind of, it's kind of been modeled in that way, although it might not be an active ideology that was put, an active ideology put into the design of Polkadot, but that is what it looks like now, and more can be done in that aspect. Decentralized web, the model of Polkadot has gradually evolved into the idea of a blockchain of blockchains, from what I've pointed out. And this is a good characteristic of nature in sustainability. So an ecosystem of ecosystems. Polkadot blockchain is becoming like a swarm intelligence system. So the having a look at the swarm intelligent algorithm or systems from nature, Polkadot kind of has somewhat same model where, you know, we're talking about the collective behavior of decentralized, self-organized systems. So parachains on their own are full-blown blockchains, and Polkadot on its own is also a blockchain. So we have this interconnectivity, interoperability in the ecosystem, decentralization. So in other words, we can kind of define the blockchain, Polkadot blockchain, as a swarm intelligence system. This may not currently be an active design ideology in building Polkadot, but it will be great making natural computational design decisions to the innovations in the ecosystem. So what is Web3? So having looked at the point nature, Polkadot, and Web3, we know that this Web3 at this point doesn't have like a complete, it's still being defined in from different angles. It hasn't fully taken shape, which is expected. So from my own definition, Web3 can be seen as a swarm intelligence system of self-sustainable, decentralized ecosystem of trustless technologies. So looking at the word trustless technologies here, this is what blockchain in itself has brought. Blockchain has brought the ability to trust transactions without the need of third-party verification and all of that. So this is based on my own definition of Web3, the way I see it currently. So in the study of, in light of all this, having followed the whole blockchain technology for years, we are building a blockchain system or network that we call the voltage network. So it is basically modeled out of natural computing. So the voltage network, it's more like, is a decentralized financial blockchain. It is part of natural computing and is inspired from physics of electricity. So looking at electricity in its own is a study. When you study electricity, the concept of electricity, electrons, the voltage, and all of those parameters, it kind of gives a good model for a sustainable type of currency. So what we are trying to do with voltage is to model a blockchain system that kind of works as the way electricity works. Electricity, we know, is modeled out of, like, it's a natural physics phenomenon. The way power moves, voltage pushes power, all those parameters, a good currency and a good kind of blockchain network can be modeled out of it. So that is our focus in voltage networks. And we are actively researching and trying to build this system.
Ugana,
So,
at what stage are you with Voltage Network? And
yeah,
what's your main role in this? This is fascinating to see how, based on nature, how it functions, etc. You're focusing on electricity and electronodes and how they move through bodies and through systems. Um, what is it that you're trying to solve with Voltage Network, and what's your role in it?
yeah, good question. So what we're trying to solve with voltage networks is we're trying to, create a good currency system that kind of backs the fiat currencies, the dollars, all the currencies in the world is able to move. Just going back to like the first principles with electricity, what powers our bulb is the electrons that is being pushed through the cables by volts. So it's like an the token within the system that we call the volt. It's like the gas that pushes the electrons from the cell or node, from one node to the other, from the cell to the load, and so on and so forth. So in simple terms, we're trying to create a more sustainable kind of currency that fully backs um, the fiat currency, and it also can also kind of solve fund transfer from one fiat currency. It's not here to overtake currency, replace our fiat currency, the dollar, the euro, the naira, and so on, but it's to place our fiat currency on blockchain, on a more sustainable blockchain that it's that's powerful and can solve issues when it comes to international transaction and so forth,
Right.
exchange and all of that.
Oh, it's amazing. Your role
Yeah.
is in this is
Yeah, so I am the CTO. I I do the research, all the technical stuff for the team, and it's a very small team. So we try to, work to grow the team and make this possible.
right. I didn't mean to interrupt you. You have a couple more minutes to finish your presentation if you'd like.
Yeah, so this is actually like my last slide.
Okay.
Yeah.
Ah, okay. Well, it's fascinating, and I think there's so many lessons to be learned if we observe how nature works and how the universe works, and how we can learn from that and adapt that and bring that into our new space that we're exploring now in Web3 and the blockchain technologies. It's really interesting, and thank you for pointing that out or showing us how that is informing your product that you're developing. Is this developed on Substrate or Polkadot?
Yes.
Yeah,
So we are building it on Substrate, Polkadot network.
yeah. All right. And then you will be bidding for a parachain at some point
Yeah.
of your own. Oh, nice to have you part of the Polkadot community, as we are here at UNIT. Thank you so much, Ugonna. It's been enlightening and inspiring, and I appreciate your research in this area and how it can enable all of us in this space to look at how systems are built. And I was especially interested in this whole swarm intelligence and how that can help us with the decentralized organisms that we are becoming. Maybe you can speak just briefly on that again, and how that works, how the swarm intelligence works, and how it can help us in our spaces.
Yeah. So more on this swarm intelligent network. So looking back to how, for instance, the termite colony, how each worker, each member of the colony can independently make or carry out its duty and still leave kind of certain information on like progress for other members to also, to also join in building or carrying out a task. So
Mhm.
there's a form of independence in from the lower level of work, and also looking at it from the higher level, every member is able to also individually work into a particular goal. So each member kind of represents its own ecosystem that does
Mhm.
something, and collectively they can be seen as one system, as a colony that achieves something. Yeah.
Right. Oh, fascinating. Well, thank you so much, Ugonna, for your time and your research, and all your insights has been absolutely great today. So thank you very much.
Yeah, thanks
Thank you.
for having me.
Uh,
Thanks.
Pleasure.